Hello students, welcome to the maths class. Today in this video I am going to explain exercise 8H of differentiation. In this exercise you are going to study derivative of implicit functions and special type of functions containing an infinite expression. Now first point is derivative of implicit functions. Before finding the derivative of implicit functions, you need to understand what are the implicit functions. So you see here in front of you I am writing two functions y equals x square plus 2x plus 1 and x square plus xy plus y square equals 0. This is first one, this is second one. Now what is the difference between these two functions? Students, first function, if you see in this function y is directly expressed in terms of x. When two variables are there and one variable is directly expressed in terms of another variable, then you can say it is an explicit function. That is an explicit function, not implicit, explicit function, because you are expressing one variable in terms of other variable directly. But in second function you can see x square plus xy plus y square equals 0. If you want to make y as subject, then it is not possible here to make y as subject, or if you want to make x as subject, that is also not possible in this case. So in this case equation is given in which mixed up x and y are mixed up and they cannot be expressed in terms of other, means x cannot be expressed in terms of y cannot be expressed in terms of x. So such type of functions are called implicit functions. So you are going to find the derivative of such type of implicit functions. This is second function, you can see. So once more time I'm telling, if a function is given in which you are having y directly in terms of x, so that is explicit function of y in terms of x. And second case, when you are not able to make subject y or to make subject x, you cannot separate the variable x or y, then that will be implicit function. So for second function, for second type of function, we are going to get the derivative, to find the derivative. Now how can we find the derivative? And a special type of function containing infinite expression, that also I will tell you in one question. So some questions of exercise I am taking, some questions of exercise 8H I am taking, so that you can understand how can we find derivative of implicit functions and a special type of functions containing an infinite expression. So you see question number 1, exercise 8H is written, you can see, and first question also I have written, solution also I have done here. Find dy upon dx if x square plus y square equals a square. X square plus y square equals a square. It is an implicit function, you can see. Now how can it is explicit function because a is constant, so you can make, but how can we find derivative? You can see here, differentiating both the sides with respect to x, it is written. So differentiation of x square plus differentiation of y square in LHS is equal to differentiation of a square. Differentiation of x square, you know, 2x. Differentiation of y square, you know, 2y dy upon dx. Why 2y dy upon dx? I told you in previous exercises, because you are differentiating y square with respect to x. So first of all, y square you will deal it as x square. X square differentiation 2x, you know. So in the same way, y square differentiation will be 2y. But it is not x, so its differentiation in multiplication, it will come dy upon dx. Differentiation of y square 2y, and it is not x, so its differentiation will come in multiplication. And differentiation of a square is 0 because it is constant. Now you can see, now simple calculation is there. 2x you can take to RHS, so 2y dy upon dx equals minus 2x. 2 is cancelled with 2, you can see. So you are having dy upon dx equals minus x upon y. So now you can see here, so easily you have found dy upon dx. It was an explicit function, now implicit function is coming. Here you can see, in this case you cannot make y as subject or x as subject. Implicit function is coming. So same method you will apply as you have applied in first question. It is question number 5. Differentiating both the sides with respect to x. So d upon dx of x cubed plus 8 into d upon dx of xy, you can see, plus d upon dx of y cubed plus d upon dx of 64. Now you can see here, d upon dx of x cubed is 3x square, 8 is same. Now here uv formula will be applied. X same, differentiation of y dy upon dx, plus y same, differentiation of x 1, plus differentiation of y cubed 3y square dy upon dx equals differentiation of constant 64 is 0. Now simplification will be done. There are two terms having dy upon dx. This term 8x dy upon dx and 3y square dy upon dx. So I have taken these two terms together, and dy upon dx I have taken common. So what will remain inside the bracket? 8x, you can see, plus 3y square, you can see. Now remaining terms together I have taken 3x square and this 8y. When you multiply inside the bracket, it will become 8y plus 8y. Now you can take these terms to other side, 3x square and 8y. So it will become 8x plus 3y square into dy upon dx equals minus bracket starts 3x square plus 8y. Now you can take 8x plus 3y square in the denominator. So dy upon dx minus bracket starts 3x square plus 8y upon 8x plus 3y square. So this is the differentiation. In this way you can find dy upon dx. This is the final answer. One more question is there, question number 9. In this question you can see this function is given, under root x plus under root y equals under root a. Differentiating both the sides with respect to x, it is written. So differentiation of root x, d upon dx of root x plus d upon dx of root y plus, is equal to d upon dx of under root a. Under root a is constant. Now you can see differentiation of root x, you know very well, 1 upon 2 root x. Differentiation of root y, 1 upon 2 root y. dy upon dx, you know very well. And differentiation of constant is 0. Now you can take 1 upon 2 root x to RHS. So minus 1 upon 2 root x it will become. 2 will cancel, like this 2 you can cancel. Root y you can take. Here you can see root y upon root x is coming. Now root y upon root x in same root you can write. So dy upon dx equals minus root y upon x. One more question you can take. This is the final answer in this question. You can see question number 13. If y equals x sin y, prove that x dy upon dx equals y upon 1 minus x cos y. How can we prove? First of all, it is given y equals x sin y. So here you can convert, you can make x as subject. X equals y upon sin y. Now you can differentiate this function with respect to y. So you will get dx upon dy. U upon v formula can be applied. Sin square y in denominator v square. Sin y v same. Differentiation of differentiation of y minus u same, u means differentiation y same, and d upon dy of sin y. U upon v formula we are applying here. So sin y same, differentiation of y is 1, because this time you are differentiating with respect to y, so its differentiation will be 1, minus y same, differentiation of sin y cos y. Now you can see, in place of sin y you are putting the value y upon x. From where you are getting, you can see here in equation 1, you can see if you find the value of sin y, it will be sin y equals y upon x from this equation, from one equation. So from this equation we are putting the value sin y equals y upon x. Now we are taking y as common, so 1 upon x cos y upon sin square y. Now how can we solve? You can see, in denominator also value of sin y I am putting y square upon x square. So 1x will cancel after taking LCM in numerator. This is the simple calculation you can do yourself. No need to explain, but I am explaining. Square root 1 square cancel with 1x is cancelled, 1y is cancelled, x upon y into 1 minus x cos y. It is the value of dx upon v dy. Now dy upon dx you know very well, you can take reciprocal y upon x into 1 minus x cos y. Now x can be taken in LHS by cross multiplying. So x dy upon dx equals y upon 1 minus x cos y, which was to be proved. So like this you can prove the question. One more question I am taking. Question number 18. Fourth part. 4 parts are there. So fourth part I am taking. Sin square x plus 2 cos y plus xy equals 0. You have to find dy upon dx. Here also you have to find dy upon dx. So d upon dx of sin square x plus 2 into d upon dx of cos y plus d upon dx of xy equals d upon dx of 0 is 0. So that's why I have written only 0. Now differentiation of sin square x, 2 sin x cos x. You know very well. Differentiation of sin square x, 2 sin x, then differentiation of sin x cos x. So that's why we are getting 2 sin x cos x. Plus 2 into differentiation of cos y minus sin y, and dy upon dx also. Here you can see, pay attention. Minus sin y dy upon dx. One more time I am telling. Here you can see minus sin y dy upon dx plus x. Here uv formula will apply. X same dy upon dx plus y same. Differentiation of x is 1. Now simplification will come. 2 sin x cos x means sin 2x minus 2 sin y dy upon dx, x dy upon dx together you take, plus y equals 0. Now from these two terms you can take dy upon dx common. So these two terms I am taking in RHS. You can take in LHS sin 2x plus y is there. In RHS 2 sin y dy upon dx minus x dy upon dx. Now you can take common dy upon dx. So 2 sin y minus x. Now dy upon dx you will get, you take this term in denominator. This term means the term which is in multiplication of dy upon dx you can take to other side. So dy upon dx you will get sin 2x plus y upon 2 sin y minus x. So this is the value of dy upon dx. Now special type of functions containing an infinite expression that is coming. You can see one question, two questions are there. One question I am taking, 20th question. if y equals under root cos x plus under root cos x plus under root cos x to infinity, prove that 2y minus 1 dy upon dx plus sin x equals 0. Now how can we prove this? This is the question. So student, it is very easy question. One time you have to pay attention what I am telling to you. Y is given this one, under root x, under root cos x plus under root cos x plus under root cos x to infinity. Now student, if one from an infinite series you delete one term, then also it is an infinite series. Means if I remove this one, this, if I remove this, so what remains? This you can see, if you pay attention only on this term, only on this term inside, so and you ignore this one, so is it y or not? Exactly, it is y. You will say, if you ignore outside under root and cos and inside under root cos x plus cos x to infinity, if you see, so it is also the value of y. So you can put here, that's why I have put here, you can see under root this cos x plus and this term I have put again y. You can see squaring both the sides, y square equals cos x plus y. Now y, terms of y you can take one side, y square minus y equals cos x. Now differentiating both the sides with respect to x, so you can see d upon dx of y square minus y, d upon dx of cos x. Now differentiation of y square, 2y dy upon dx minus dy upon dx equals minus sin x. Now you can take dy upon dx in LHS common, so 2y minus 1 dy upon dx, and this minus sin x you can take in LHS, so it will become plus sin x equals 0. So now you have seen how easily we have found the value of, we have proved what was to be proved, we have proved. How easily we have proved, you have seen. It was looking so difficult question, but only one step you have to keep in the mind. In an infinite series, if you delete one term, then also it is an infinite series, and you can take inside this inside term as y. So I hope you have understood what I have explained, and after getting this video you can solve all the questions of exercise 8H. So if you have any doubt, then you can ask. So thank you and have a nice day.